Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this video, we will continue our project where, if you remember in the last video, we wrapped up with the descriptive stats. We have discussed its significance. We have talked about correlation coefficient, its significance, types of distribution, how median is more robust than mean for the outliers part per se, and then we have seen the data imputation, that at what point of time we should go for mean and at what point of time we should go for median. So at the end we made a conclusion that, let's say, if we will be having a symmetric data, in that case it would be a better choice to go for a mean imputation part per se. And if, let's say, we will be having a non-symmetric based data, maybe a skewed data, in that scenario it would be a better choice to go for a median imputation, right? Because of the reason of more robustness to the outliers in case of a median. Now, in this session, we will continue our EDA task where our focus is majorly on that, okay, we do have the complete analysis of a data. We have already done the imputation as well. But now let's try to understand let's try to examine whether we will be having outliers in our data or not. And if yes, how can we handle those outliers? Again, for this, a bit of maths is required. I will try to showcase you each and everything just like the way I have done in the previous session while explaining the concepts of mathematical part here also. So what we can do here is, first of all, we will try to see in the very first go in this session that how we will be able to detect the outliers. So first task is the outlier detection. Now, in order to examine the outliers, at the very first go, what I will do is I'll try to split my data into, I would say, input features and target value. Because as of now, if you can see, all the values, which is pregnancies, glucose, BP, skin thickness, till age, I know all these are the input features that I have. And outcome is something which is the target value. So what if I try to split my data into the input features and the target value? So what I will do is, maybe I will take X, which indicates the input features, and I'll take Y, which indicates the target value. So now what we will do is we will try to split our data into X and Y. So how can we do so? A very simple use case. Basically, what we can do is we can simply drop the values of the outcome, right? So what we can say data frame dot drop. Drop will help me to drop the last column which I have, or maybe any column, whatever you want. But in this case, I just want the outcome column. So I can say columns is equals to outcome. And at the very end, you just specify what is the axis. It's a column wise. I want to delete the column name outcome. So I can do that. After that, Y is something which is equals to data frame outcome specifically, right? So what I have done, simply I have deleted the values of outcome in the X part so that I will be having only the input features. And in the Y part, I have just chosen the outcome so that I will be having a target column available with me. Now X and Y is with us. What's next? What we can do here? Let's try to understand how can we detect the outliers, right? This is the task now which we have to perform. So let me delete it from here and let me write it here. Outlier detection. Now, there are multiple ways to detect the outliers, but the very famous way or very important plot which everyone should know is box plot. This is one of the crucial understanding which everyone should be having with respect to the outlier detection part, because this is one of the famous plot which is specifically famous for outliers detection only. We do have violent plot, we do have another ways like z-score empirical formula. Maybe in future sessions, in future projects, I will talk about those things as well. But for now, this is something which in industry many people are using. Common way, I would say. So let's try to understand the maths behind that, right? So what I can show you is, you can again see we are applying a fig size. So it will try to create a figure size of 15 cross 15. I have used here subplots function because in within one plot, I want all the box plots for all the features that we have. And then inside this, I have specified sns.boxplot, which kind of data. So X is my data for which I'm looking for a box plot, right? And at the end, I'm saving that as a boxplot.jpg, so that will be saved. So now here you can see beautiful box plots we will be able to get here, right? Now, let me try to download this particular box plot that we have, and let me try to explain you this particular plot, what it is trying to signify. Then only you will be able to understand the maths behind this. So let's try to understand the in-depth understanding of how this box plot is working, what is this diagram indicates, each and every point. Okay, let me open one epic pen for the illustration per se. Okay, now what we have to understand, let's try to see that in a box plot you will see this is called as upper whisker, this is called as upper whisker. So as of now I'm trying to explain the concept with respect to glucose feature that we have, and same concept is applicable for all the box plots that we have for all the feature values that we have, right? After this you will be able to observe this is called as lower whisker. I hope my screen is properly visible to everyone. Lower whisker. So this is lower whisker, this is upper whisker. Now this is Q1, this is Q2, this is Q3. Q1 is nothing but a 25 percentile value which you will be able to get. Q2 is nothing but median, which you can say is a 50 percentile value, and Q3 is 75 percentile value. Now what is the meaning of outlier? Simple meaning is that any value which lies above upper whisker or any value which lies below lower whisker, that will be considered as an outlier. For example, in insulin, if you will be able to see, there are lot many outliers. All these are the part of outliers. Okay? Similarly, if you will be able to see, all these are the outliers. Similarly, you will be able to see all these are the outliers. So with respect to every feature, we can see there are lot many outliers. Glucose is the one which doesn't contain for now any specific outliers. So can you see? I hope it is clear now that in a box plot, it is composed of 5 important values: Q1, Q2, Q3, lower and upper whisker, right? So if there is any value which lies outside upper whisker and lower whisker, that will be considered as an outlier. In terms of presentation per se, you can consider these ball points which we have. All these are the outliers in my data. This is the way to detect the outliers. Now, how can we deal with these outliers? For that, there are different ways. There are empirical formulas with the help of which we can handle that. There are ways with the help of which we will be able to evaluate what is the value of upper whisker and lower whisker, and then whatever values lie outside that range, we will try to remove it completely. There are multiple ways. So I will try to showcase you one of the way with the help of which you will be able to understand that how we will be able to deal with the outliers, right? So what we can do now is, maybe let's try to understand the maths behind the calculation of how can we evaluate the values of upper and lower whisker. For that, let's take one example with the help of which you will be clearly able to understand. So maybe I will be having a box plot, right? I will be having a box plot. Let's say this is a box plot that we have. So I'm trying to display in the horizontal direction for now. And this is something that we will be having as the lower whisker, and this is something that we will be having as the upper whisker, right? So this is Q1, this is Q2, this is Q3, this is lower whisker, and this is upper whisker, right? So what we will try to do here is, we will try to compute the value of upper and lower whisker. So it is nothing but 1.5 into the value of IQR plus Q3, right? And this is Q1 minus 1.5 into the value of IQR. So this is the major formula to evaluate the value of lower and upper whisker. Now what we will do is, we will try to apply this similar formula uh, in our code to get rid of the points. So what we can do, once we will be able to evaluate that is there any point outside this range or outside this range, we will be able to understand that okay, all these are the outliers and we have to remove them. Now you can ask me one question for those who are not aware about the stats idea. What is this IQR? Although I am assuming that you are already aware about statistical concepts, but still I am explaining in a very brief shell. If still someone is facing struggle, it means that there is a lag in stats concepts. Please pay attention towards that. You can just first of all focus on those concepts and then maybe you can come back here. So here IQR indicates the interquartile range. quartile range, whose formula to evaluate is the difference between Q3 minus Q1. So basically what we usually does is we usually try to calculate the value of IQR by looking into the difference between the Q1 and Q3. And as I told you, Q1 indicates 25 percentile, it is 75 and it is 50. So we will try to see the numbers between the range of 25 and 75, and we'll try to take the difference between these two values. What is the value correspond to Q3 and what is the value correspond to Q1? Perfect. So what we can do now is, we know we do have multiple columns, right, available with us. We know we do have multiple columns available with us. Now I'm trying to showcase you the code to detect the outliers. Here you can see we have multiple outliers available in different features that we have. So what we will do is we will write the column names that we have. So we have pregnancies, we have glucose, we have BP, we have skin thickness, we have insulin, BMI, diabetes pedigree function, and we have age as well. So what I have done, I have tried to note down all the values in the list name columns, calls, which indicates columns. Now what we can do, we can traverse in the entire list, and with the help of this quantile function, we will be able to get an idea that what are the data points that we have which lies among 25 percentile, and what are the data points which lie among 75 percentile. So if you want to look upon that what is the internal maths behind calculating the quantiles, which is 75, 25 or 50, please look upon the stats concepts. It is very, very simple. I'm not going in that much depth because the agenda is to provide you the use case or the project part per se of machine learning, of logistic regression, right? If I'll go in that much depth with respect to stats concept, then the videos will be very, very long, right? Which I don't really want. So that is the major purpose. Please try to have an understanding of these things. But in a nutshell, it is trying to convey 25 percentile index, 75 percentile index values which are available. So basically, you will be able to get the value of Q1 and you will be able to get the value of Q3, which lies among 25 percentile and 75 percentile. Now, as I told you, IQR is nothing but is a difference between the Q3 minus Q1. So you have tried to evaluate that, and with the help of which you will be able to get two values, lower bound and upper bound, or you can say lower whisker or upper whisker. Once you get that, you will try to store all those records which are either above lower bound or below upper bound. So all these are the mask values which you have taken. So if there is any data point which lies among this range, that is a point which you should include, because if there is any point which is above lower bound or above upper bound, obviously that is a point which you have to avoid. Lower than lower bound and upper than upper bound, all those are the outliers. Just now we have discussed, right? So any point which lies among lower and upper bound is a point which is not a part of an outlier. So what I have done is I have tried to store all those records which are not a part of an outlier. So this will help me to reduce maximum outliers in a way. But definitely apart from this, there are multiple ways which we have to explore in order to remove them. For example, you can look upon the quantiles, that if, let's say, as per empirical formula in stats, if you are aware, 95% of data points are among mu minus 2 sigma to mu plus 2 sigma. So what if I'll take until 95 percentile value data points, will it be able to remove the outliers or not? So all these statistical things you have to do to improvise on top of this. For now, I am showcasing this thing. So let's run this particular code. And now we have a masked records. What we will do now is we will try to take only this masked data, and that is a part of our X and Y. One thing which you will be able to observe here, if I'll just show you X dot shape, so you will be able to see, as of now, I will be having 768 number of records and we will be having 8 number of features. Even if you will see Y dot shape, you will be able to understand we will be having similar number of records that we have. But now let's say we have applied the outlier X underscore, you can say removed or removal after removal, or maybe you can mention after outlier detection maybe. As of now, this is the naming which I am getting in my head, but obviously you can rename it in a better way. So as of now, I'm writing this name, right? So we will be able to get our new data points which are after outlier detection we will be able to get. If you will check the shape of these points, right? So you will be able to see now somehow initially number of data points was 768. For now, it is 759. Very small data points as an outlier completely removed, right? Similarly, if you will check for the Y outlier detection shape, it will be also same. So in a way, we have reduced few data points, right? But still, there will be outliers available. So you have to explore the proper appropriate range where there will be no outliers. Or I would say ki don't focus on the 100% completion of outliers, but yes, maximum outliers you should be able to remove. That's the ultimate target you should have. So this is one of the way. In the upcoming session, I'll discuss the second way also, then third way also. So the target is that in further projects we will discuss further ways also, so that in every project we will learn something new. This is one of the way, right? Now this is all about the discussion of the outliers detection, where we have explored towards the box plot. Again, we have violent plot also, which does the similar thing, but as of now we have explored towards the box plot, and how with the help of that box plot, with the knowledge of that, how we will be able to determine the lower bound and upper bound, and how we will be able to get only those records which lie between these ranges. That's what we have discussed. Second important thing which we have to take care of is the concept of standardization or normalization of values. Now, what is the issue with these points? In the box plot, you will observe in this picture the values. If you will be clearly able to observe here, the values that we have, right? The values that we have. Some values are very low, some values are very high, some are again very high, some are again very low. This is a kind of format which creates biasness to the model. Why? Because your model will assume ki, let's say, I will give you one simple example. Let's say I have two data points. One is age and one is population. You will be having one data set where there are two features. One is age, one is population. Now, age cannot be more than 100. Maybe some people may have 105, 110, but not more than that, right? But population can be among millions, in crores. So, what is happening is, if let's say you will be having some data point where you will be having two features, one feature is having a specific range, which is very, very less. Another feature is having very huge amount of range. So what will happen internally? Your model will be biased towards one feature. It will assume कि अच्छा, this feature is having a maximum priority as comparable to the age one. But this is not the scenario. I don't want this thing to happen. So for that, there is a concept of standardization. There is a concept of standardization to remove this particular biasness. That is where we will learn now that how basically we can remove this kind of a issue. For this, we have two methods in machine learning. For this, we have two methods in machine learning. One method is called as, you will observe, standardization. Another one is min-max scalar. So how can we do that? Let's try to understand that concept as well. Now, as it is a part of a pre-processing, so what you will do, you will try to use sklearn.preprocessing tool. You will import the standard scalar. And after that, you will apply fit underscore transform method. Now, what is happening internally? It is trying to convert your data into a standard normal form. Again, a bit of maths, or I would say stats is there. Standard normal form. What is the meaning of this? The simple meaning is that a form where the mean will be equal to 0 and standard deviation will be equals to 1. Will be equals to 1. Okay? So what you're trying to do here, you're trying to do a pre-processing. You're trying to import a standard scalar here, and then you're using a model of standard scalar, and you're trying to fit your model. So once your model will be fit, now what will happen is, once you will try to apply a box plot on this updated data, which is, I think we need to do for x underscore outlier detection, because that is the data which we will deal now. Okay? And then maybe I will say the new name as x underscore scaled. So let's do it again. So now our data is scaled, right? So now if I just show you the scale data once again, how will it looks like? You will see the difference now. So what I am doing is, I am trying to use this new data, which is x underscore scaled. Just try to see this data. Can you see? All the data points are in one specific range. All the data points are in one specific range. And still, if you will be able to observe, there are many outliers which we have to get rid of, right? Which we have to get rid of. So maybe another way could be to use that quantile approach which I was talking about, right? So with the help of which we will be able to understand how can we get rid of that outliers. But as of now, I think the major target of using the standardization is pretty much clear to everyone, where what we are trying to do here is we are trying to define a similar range of values to each and every data point. If you want to see the descriptive stats of this x underscore scale data point, if I'll use describe function here, you will be able to understand that what's the issue, x underscore scaled. I think this is the name, right, that we have. I think this is not a data frame. That's why it is a issue. So maybe what we can do is we can create a data frame first. Maybe I can say x underscore scaled is equals to pd dot data frame, and inside that again you can mention x underscore scaled, and then I think it should work. Yes, it is working fine. So basically now you can see our mean is approximately equals to 0. Now don't say it is not 0. You can see exponential to the power minus 16. So it is ranging towards 0 only. And you will see standard deviation is approximately equals to 1. That is the literal meaning of doing a standard scalar. Another way could be min-max scalar, where it will try to take the values of minimum and maximum and will try to do the conversion. Any one of the way you can use it. Okay? So this is the overall idea behind the standard normal form, or I would say standardization. Now, in upcoming projects, you will observe I will not use standardization. I will maybe use the concept of min-max scalar. Although the concept is same, we just have to import min-max scalar and you can do your own research as well. But for the different idea perspective per se, I will try to showcase you different concept. In the upcoming video, I will also try to showcase you that, okay, we have seen how with the help of this knowledge of this lower and upper whisker or lower upper bound, we will be able to reduce somehow the number of outliers, but still there is a lot more which is pending, right? So what is the second approach which we can use in order to avoid this outlier thing? That we will discuss in the upcoming session. So in the part 3 of EDA, two things we will discuss now. One thing is that further second way of removing these outliers, right? So we will discuss approach 2 of quantiles to remove the outliers. Until so far, we have talked about only first approach, which is with respect to, I would say, right, with respect to, we have talked about box plot knowledge. Second thing which we will discuss is imbalancing of data, how we can handle that, handling of imbalanced data. But before I'll wrap up this particular video, one important and interesting thing which I really want to talk about here is, if you will be able to observe, if I'll ask you that, uh, how we will be able to again detect the imbalanced data first of all, what's the approach behind that? So if you can see, we will be having y, right? If I'll say y dot value underscore counts, let's see what we will be able to get here. Can you see? It is this value underscore counts function indicates that how many number of values are zeros and how many number of values are ones. And you can clearly see here that we do have 500 zeros and 268 ones. But if you will be able to see, we are not dealing with actual data. We are dealing with the updated data, which is y underscore outlier detection. So let's focus on that point per se, because now we are just having 756, I believe, number of points, 759, right? So let's try to see with respect to this data, how many values are there. So you can clearly see that number of zeros are almost double than the number of ones, which is a major issue. As an ideal case, when you're dealing a classification problem, your number of zeros and number of ones should be approximately equal. If there is a difference also, it should be, let's say, 10% minimum. But here almost 50% data points are more in class 0, which makes sense also. You will observe, especially in healthcare data, that's a major issue in real life. Why? Because the patients who are genuinely in a problem, for example, let me take a very simple example. The data available for non-cancerous patient is definitely more than the cancerous patients. I hope it makes sense, right? Similarly, the data which is available for diabetic patient will be less as comparable to non-diabetic people in the world. So that is why that is a kind of a issue which is coming up. So we will discuss how we can handle this issue. So now, as a wrap up, what we have discussed in this video, concluding part, as a concluding part, we have discussed majorly two things in this session. First thing is detection of the outliers, how we can detect that. And we have seen how we can handle that with approach number one. Second thing which we have discussed in this particular video is that how we will be able to do the normalization via standard scalar form, where we are trying to convert our data with a mean value 0 and standard deviation value as 1, right? Normalization via standard scalar form makes sense. And we have discussed why it is important. Why it is important. So that we will be able to reduce the biasness in the model. I hope it makes sense. Makes sense? So this is the idea. I don't want to make it further big session. Maybe in the upcoming session, that will be the last part of the EDA. If you can observe how detailed, in a detailed sense, I'm trying to convey this EDA concepts. The only reason is that this EDA you will observe in the companies also when you will go, you will spend 90% of your time in the EDA part itself. Because the higher quality data you will be able to generate, there are better chances that you will be able to have a better accuracy, right? So please try to understand all these concepts in a very great manner. Sometimes you might feel that there is a lag in the sessions because I'm using some statistical words which might be jargons for you. The only thing which I will say in that particular note is ki please try to have the knowledge of stats concept. Somewhere if you're feeling ki I'm not able to understand that statistical part, maybe you can take the help of other resources where you can understand the stats concepts, and then maybe you can come back and try to understand what I'm trying to convey there. That's the only thing which I feel you might miss if you're not aware about the statistical concepts, because in EDA stats is very very important, and here I'm not covering up stats in that much detail because of the limitation of time. That's the only thing, right? With this, let's end today's video. I'll see you all in the upcoming video where now we will discuss the further part which is pending, and then we will discuss in the upcoming sessions how we can do the final modeling and prediction of the logistic regression model which we want to cover up here. So I hope that you are really enjoying these sessions a lot, and I'll see you all very soon in the upcoming video where we will proceed with the EDA further.